Morning, everyone. I hope you guys are doing well. This is our second class. We are recording. It will be uploaded. I'll tell you what my plan is. I will finish 2.1 today. We're going to talk about a couple of things that some of you might find a little challenging, so bear with me. And we'll start chapter 2, section 2, 2.2, section 2, chapter 2. So other than that, do you have any questions? Do you have any questions for me? The problems you tried from chapter, I'm just going to say from 2.1. 2.1 means chapter 2, section 1. If you have any questions, you don't want to ask now, that's totally fine. You should be able to do, based on what we did, you were capable of doing most of the problems except for the last few, which we will address today by the end of today's lecture. Ideally, and hopefully, you will be able to do all the problems from 2.1. And hopefully, if we wrap up 2.2, I don't know what's going on. So anyway, I don't know why there is an echo, but just mute yourself, guys, if you don't mind. Mute yourself. Thank you, Richard. Not a problem. And just to let you know, guys, okay, you have any questions, you can always mute yourself and ask. You can ask me to repeat something. You can ask me to do another example. You can ask me to explain something again. No problem, okay? Unmute yourself and feel free to do so. But the good news is everything is being recorded. That's that's the good news. One more thing. Again, it's just something I'm reminding myself. Our first exam will be on June 20th. You will be given a period of 24 hours to take the exam. I will give you 2 hours, and that's more than enough time, guys. If you do the work, if you study, if you keep your notes handy in front of you in a notebook or in a Word document, okay, on your computer or Jump Drive. And I would recommend that you do that. Keep your notes in a Word document. I like Word documents better than hard copies. It's just a personal choice. If you keep your notes handy in front of you, it's going to help you a lot. Okay. As you know, it's an open book exam. So that's also a piece of good news. Let's go ahead and wrap up 2.1.
Will we have a class meeting on the 20th as well as the exam?
Good question. No class meeting on the 20th. Very good question. Once again, on the 20th, we don't meet. You just take the exam. I know the class is about 1 hour and 15 minutes long, but I will give you 2 hours. Why? The assumption is, it's an online exam. I'm giving you a little bit of flexibility, and I won't be able to give you extra time. And I'm talking to everybody, not just Matthew. You won't get any extra time. You have to start within that 24-hour period and take the exam. I hope I answered your question, Matthew. Okay. So guys, this is something what we're going to do right now. Let me get rid of this. I think I need this. Okay. So I'm going to define, okay. Excuse me. So I hope you can see my screen. I'm sure you can. Let me double check if I'm recording. Yes, we're recording. All right, guys. So we're going to talk about these two formulas. Okay. These are two very important formulas from 2.1. And you might say, oh, that's easy. It's an open book exam. I'll just write the formulas and I'll answer your question. You won't be able to. You have to understand what the formula means. Okay. If you don't understand, you won't be able to apply them. So try to understand that, what I just said. So let me, before I jump into, by the way, once again, this is 2.1. We will start 2.2 and hopefully wrap it up as well. This is arc length. What is an arc? Let's go back and discuss that first, okay? By the way, if you don't understand something I said, just unmute yourself and say, can you explain that again? Or what, could you repeat that? Not a problem. You can also write on my screen. I don't know exactly what your interface looks like. I don't know, but if you hover over the little strip where it says Zoom, you should get a button that says annotate. And once you click it, you should be able to draw things, write things on my screen. And if you want to point out something, you will say, I don't get that. What did you do there? I'll say, can you point it out? Can you use your marker pen to write? Many students pick it up really fast because you guys are younger than us. You guys are more tech savvy, okay? So fiddle with it. If you want to interact, you can. That's not a problem. All right, guys. Um, all right, guys, let's get back. Here is a circle, okay? And last class, we learned two formulas from middle school. The circumference, which is the length of the boundary. Some people use the word perimeter, okay? Is 2 pi r. R is the radius, okay? This formula will come in handy and you have to know it. The next one is the area. The area of the circle is pi r squared. All right. Now, again, I'm repeating myself. This is the circumference, length of the outer boundary. It's given by this formula 2 pi r, where r is the radius of the circle. It could be 5, 6, 7, 8. And area A is basically how much the circle covers. For instance, you have a carpet in your living room that's circular, and you want to know how much of the floor is being covered. Or you want to make a garden that's circular. You want to know how much of your property will be covered by the garden. Maybe you want to cover it with stones, and that's why you need to know. You want to keep them straight, okay? Which is which, and what do they mean? All right. Having said that, this is something we have reviewed. It should be in your last video. Another important term is called an arc. It's not spelled A-R-C-H. It's spelled A-R-C. A-R-C. Arc. What is an arc? Okay. Arc is a part of the perimeter. Generally, we're talking about circles. You could say circular arc. But in this course, we will be mostly talking about circles. So we don't have to say a circular arc. We can just say arc, and that's what it means. Okay, we are going to learn how we can find the length of this arc. Okay, that's what the first formula is about. And generally, this length, okay, we don't use the letter A. We say this length is S. I don't know why they chose S, but that's the letter they chose, and we're going to stick to it. All right, so let's say, I'm going to get rid of this. I'm going to do a little better job drawing. I have a circle, okay, and I have a little pie slice, this much, okay, and this angle is theta. What is theta? It's so as of now, it's just a Greek letter we use to label an angle, okay? Theta. Let me see if I can write. Yeah, that's how it's written, okay? It's pronounced theta. T-H-E-T-A. Let me write it down once. I'm not going to write it down every day, okay? Theta. It's a Greek letter. And if you want to write it by hand, it's going to probably look somewhat like this. Most people write it like this, okay? So basically, it's a 0 with a little horizontal line in the middle. This angle is theta, okay? Theta has to be in radian, okay? Why radian? Because when your angle is in radian, your angle will have some pi and things will cancel and your result will be very convenient. So whenever we find this angle in this section, we are going to say theta must be in radian. Now, last class, we learned, okay, give me 1 second, let me fix that. Last class, we learned, by the way, there is a thunderstorm warning, and that's probably what you can hear. This is theta, and I'm going to say it must be in radian, and that's very important. Must be in radian. If I give you the angle in degree, you have to convert it. And that's what we learned last class, how to convert theta to radian and radian to theta. Initially, I'll give you the angle already in theta, 2 theta, 3 theta, 4 theta, something like that. Now, I want to know this length, this length. I'm going to call it S. That's what we use. Okay, this length is S. And I don't, I'll save the formulas here. I don't need them right now. So bear with me a little bit. It's a difficult concept when I teach it in class, face-to-face classes. Students say, can you do that again? So bear with me a little bit. All right, guys. So this angle is theta, which is in radian. Okay. Now, I would like to claim whole, let's say the radius is r. Okay, the same r right here, right? I actually don't need this. I'm going to hide this formula. It's just a distraction right now. We're going to use it later. So, okay. So I am going to claim, guys, this S is a fraction of the whole circle. So it's very easy to see. It's very easy to see here. Okay. Look at this cake. Okay. Somebody baked this cake for you and you really like the icing on the edge. Okay. Let me bring this here and write on it. You want to be a little patient and you want to understand what we are trying to say. So if you want the icing, oh, let's change the color to think something is eye-catching. If you're really interested in the icing, if this angle is 1/4, the icing will be 1/4 of the whole circle. And this angle must be given to you in radian. So remember, guys, the whole circle has an angle of 2 pi from last class. And of course, 2 pi is 2 pi is 360. Or if it's a half circle, it's 180. That's something you want to remember. And we kind of established that pi in radian. I'm not going to write radian anymore. We don't generally write. Pi radian is 180 degrees. So what I'm really trying to explain is this. This arc length, or S, is going to be a fraction of the whole circle. Well, what fraction? Well, whatever fraction this angle is. If this angle is 1/4 of the whole angle, the icing that you really like is going to be 1/4 of the whole circle. That's the concept you really want to understand. And that's really not that difficult for, adults, because we know if this is 1/4 of the whole circle, this angle must be 1/4 of this whole circle, which is 360, because pi is 180, therefore 2 pi is 360. That's the basic concept that we're going to use. Now we're going to go back to our old slide. And this I did for my other class, so I'm going to delete it. It's just a distraction right now. Give me 1 second. Okay, so guys, what I'm saying, if this radius is r, this whole circle is 2 pi r from this formula. I'm going to write it down. S divided by 2 pi r. That's the fraction, right? This little s divided by whole thing must equal theta divided by 2 pi, 2 pi. Why 2 pi, guys? Remember the fraction we talked about? This fraction, this angle, divided by the whole circle, which is 360. 360 is 2 pi. And we like radian. Why? Because things will cancel. We will have a clean formula. Now, this is coming from the concept that S, this arc length, divided by the whole circle, is the same fraction as this angle divided by 360, but we don't want 360, we want 2 pi because things will cancel. So this is a crucial thing you want to understand and you want to reflect on. I'm not done. I'm going to wrap it up. Then I'm going to ask you if you have any questions. So I'm going to take this. Now I can actually cancel 2 pi and 2 pi because they're both in the bottom. If you don't like what it like the way it sounds, you can say you can multiply both sides by 2 pi. You can do that. And if you multiply both sides by 2 pi and 2 pi, they go away. This 2 pi and this 2 pi, they go away. And I'm going to get rid of my writing. That's the explanation. So I'm going to just say that means due to the cancellation that I just showed, there's a little 1 here, and theta divided by 1 is theta. So I'm just going to write theta. Sorry. All right. This is much better than this. I want S. What is the arc length? That's what I want. And I'm going to multiply both sides by R now, like so. Multiply by R, multiply by R. So on the right-hand side, you will have R theta. On the left-hand side, the R's will cancel. Let's get rid of this and clean up our formula. And I'm going to write R theta. Okay, this is the first formula that we talked about that you really want to understand. The first formula is the arc length S. I don't need this. Arc length S is given by R times theta. R is the radius of the circle. Excuse me, guys. R is the radius of the circle, and theta is this angle. That if you really want me to be formal, theta is the angle that this arc subtends at the center. You don't have to be that fancy, okay? You can just say theta is this angle. Okay, this is the radius. So if you know the radius and you know the angle, you can find this arc length by using this nice and clean formula. Again, theta must be given in radian. If in the question it's given in degrees, you have to convert it. And when you do some of the problems or you ask me to do it, I'll do some today anyway. So it'll click. Let's pause there a little bit. At this point, I only want you to know this formula. I want you to know background so that you know what it means. Otherwise, you won't be able to apply it anywhere. Give you a couple of minutes, okay? Literally. Just see if you want to process and then say, can you explain that again? Those things. All right, guys, hopefully things are okay. If not, you can always interject. That's not a problem. So let's kind of do something very similar and derive or understand the second formula. This is the, let me see if I can go there. This is the first formula. S is R theta. Again, you want to write it down somewhere, you want to have it handy. You want to know what arc length is, length of the arc. You might wonder what an arc is. Arc is a part of the circumference of the circle. So it's all of this is in our lecture. Okay, so just knowing the formula won't help you. Again, theta must be in radian. That's what it's saying. Now let's do this one. This is actually, if you understand the first one, the second one isn't that bad. Okay, so let's go back to our cake model. So let's say this time, now I know it's a three-dimensional cake that I have, but let's say I'm just concerned about the top and somebody will give you this much. Somebody, your mom, will give you, let's say, this much cake. That's about a quarter. That's what I'm trying to mean, okay? And this can still sit here. I will use them. Okay, this time you're concerned about how much cake you got, how much of the top layer you got, the area. Okay, now I'm gonna claim if your mom gives you a quarter of this cake, let's assume it's very small. That quarter, 1/4, is gonna be same as just like before. This angle divided by the same 360, but again, we don't use 360, we use 2 pi. Why do we use 2 pi? Things cancel, the formula looks much better, okay? For the sake of simplicity. So same concept, but this time we're gonna use the area formula. We are interested in the area of the whole cake, the top area, okay? The top area of the whole cake. First, you take your slice. What area is your slice? That's what you're interested in. And we use A for that, not S. A for area, and we divided by the area of the whole circle. So that's the kind of argument we're going to put forth. So this time, guys, I don't need this. So let me gradually erase things. Okay, this is the same theta. Okay, I don't think I need this time. I'm going to delete it. I'm going to come back here. Sorry, this time I'm going to use this. Now, this time, somebody gave me this much of a cake, whatever this much means. All right, the angle, they are telling me the angle is theta, which is given in radian. Okay, so I'm going to claim, okay, well, the slice of cake I got must be the same fraction as theta divided by 2 pi. Theta is this angle divided by 2 pi, which is the whole circle, which is 360. Well, this part is okay, but I have to fix this part. This area is A. Why A? Because we use the letter A to represent area. That's why. We are deriving the second formula. This is A, but remember, guys, if A is the area of this sector, by the way, this pi slice is called a sector. Let me write it down here. It's a fancy word. Actually, it's not that fancy. If you take a pi slice of a circle, it's called a sector. So you're going to hear me say that word a little bit. It's called area of the sector right here. So this area that I shaded is A. The area of the whole circle is not 2 pi r, it's 2 pi r squared. Now I'm going to get rid of this. I'm going to get rid of this. Once again, the angle theta divided by 2 pi is same as the area I am looking for divided by the area of the whole circle. And we are using the area formula, not the perimeter or circumference formula. Now it's kind of the same deal. I can get rid of pi, and that's nice. It simplifies my formula. And people who do math, they always like simpler things. I think everybody likes things that are simpler. All right, this is what I have. That's much better. I don't have to worry about pi. Now, I want this formula A is equal to what? I'm going to multiply both sides by r squared. I can do that as long as I do it with both sides. I'm fine. This r squared and this r squared will cancel, but I will have an r squared here. Let me get rid of this. Oops. I don't need this. So next line, I'm going to write what I expect to happen. On the left-hand side, I only have A. On the right-hand side, I have r squared. Now, you can write this formula as I have written here, theta r squared over 2. You can also write this formula as follows. They mean the exact same thing. Okay? So, take a look, guys. Okay? I'm going to write the formula here, both formulas, and we're coming from here to here. Okay? Dividing a number by 2. Here by a number, I mean theta times r squared, whatever that is. Theta is your angle in radian. R is just the radius of the circle. Okay, that's a number. That's going to be a number. Your calculator will give you a number. You are dividing it by 2 is same as multiplying it by half. Okay, another way of writing the same thing. Okay, so if we can use either one or actually any one of the three, and you should be able to follow. Okay. 0.5. I can put a multiplication sign up. I don't need a multiplication sign. So, okay. So this time is half is 0.5. We can also write 0.5 times theta times r squared. Okay. So we derived our second formula. And I'll pause there a little bit, guys. Okay. Just a little bit to see if you have any questions. Why did you do that? All right, guys. I don't know if I gave you enough time or not, but we have derived these two formulas. Okay. And what are they saying? The area of the sector. Remember I said that fancy word, area of the sector of a circle of radius r formed by a central angle theta radians. Again, they're emphasizing theta must be in radian. If somebody gives you that angle theta in degrees, you're okay, but you have to convert it to radian. Okay, so I think I'm ready to do a couple of problems from 2.1. And so it's not a bad time to jump out of the session and come back really fast. I'm not going anywhere. We're going to do some examples from your text. Okay, guys? This will kick us out in 10 minutes. There's no need for them to kick us out when we can come back on our own. I'll see you soon, guys. Like in 20 seconds. Bye.